In the last class, we derived voltage and current equations. From that voltage and current equations, we got V of x as what? V naught plus e to the power minus gamma x, that is forward voltage, plus reverse voltage, that is V naught minus e to the power gamma x. Similarly, current also I of x, it is also consisting of forward current, that is I naught plus e to the power minus gamma x, and reverse current, that is I naught minus e to the power gamma x. So these are the voltage and current equations of the transmission lines. And we obtained this dV by dx, this dV by dx is equal to what? I into R plus j omega L. Please make a correction. Actually, dV by dx. dV means what? V2 minus V1. dx means what? X2 minus X1. We are moving the length of the along the length of the line. That means length is increasing. As length is increasing, as voltage is passing through the transmission line, voltage is decreasing because of lossy nature. So here dV can be written as what? V2 minus V1. Generally V2 is less than the V1. That's why generally here you have to take minus. Okay, please make a note of this one. Actually I have written this one as what? dV by dx equal to I into R plus j omega L. What I did there? V minus dV. But we have to take what? First V minus dV minus V. Then in that case you will get minus dV by dx. Similarly, minus di by dx is what? V into g plus j omega c. Now let us substitute this one, that is d by dx into V naught plus e to the power minus gamma x plus V naught minus e to the power gamma x. Similarly, what is I? I naught plus e to the power minus gamma x, I naught minus e to the power I naught minus e to the power gamma x into R plus j omega L. Here simply we substituted V and I. Why we are substituting? Basically here we have impedance. Impedance is what? Ratio of voltage to the current. So here characteristic impedance is defined like this. It is defined as forward voltage to the, generally here I am writing, it is defined as like this, that is forward voltage to the forward current. Forward voltage to the forward current. It is the definition of what? Characteristic impedance. In order to get the forward voltage by forward current, we need to do what? We need to take the ratio of this V naught plus e to the power minus gamma x, that is forward voltage, divided by forward current I naught plus e to the power minus gamma x. In order to get that, we require this equation. In order to simplify this equation, what we required? Voltage and current equations. Now let us simplify this one. You will get what? Differentiation of this one is nothing but what? V naught plus is constant, e to the power minus gamma x with respect to gamma x, differentiation gives what? Minus gamma. Already here you have minus, this becomes what? Plus gamma. Here we have minus, that is this V naught minus is constant, differentiation of e to the power gamma x with respect to x is what? E to the power gamma x into gamma. This minus is because of this minus, and it is equivalent to what? I naught plus e to the power minus gamma x plus I naught minus e to the power gamma x into R plus j omega L. What it is saying? Forward voltage, that is V naught plus e to the power minus gamma x divided by I naught plus e to the power minus gamma x, e to the power minus gamma x, e to the power minus gamma x cancel, V naught plus by I naught plus. What it is? A required characteristic impedance, that is Z naught. Remember this one. We need to derive this V naught plus by I naught plus. We have to get what? V naught plus by I naught plus. Here we have V naught plus, here we have I naught plus. In between that, we have equal symbol. When these are equal, if they satisfy this condition, First of all, answer this one. If I say a plus jb equal to 2 plus j3, what about the a value and b value? A equal to 2 and b equal to 3. How we can say this one? By equating the similar terms. Here also, as we have equal symbol, we have to equate the similar terms. What are the similar terms? E to the power minus gamma x, here e to the power minus gamma x. E to the power gamma x, here also e to the power gamma x. Let us equate the similar terms. By equating similar terms, by equating similar terms, we will get, we will get what is the similar terms, what is the term on left hand side that is similar to right hand side? E to the power minus gamma x, e to the power minus gamma x. On left hand side it is v naught plus e to the power minus gamma x into gamma is equal to I naught plus e to the power minus gamma x into r plus j omega l. Here e to the power minus gamma x, e to the power minus gamma x is cancelled. What we required? V naught plus by I naught plus according to the definition of the characteristic impedance. Remaining is what? R plus j omega l divided by gamma, where gamma is what? Already we have gamma. Gamma is under root r plus j omega l into g plus j omega c. This is the gamma. Now we can write this one like this: under root r plus j omega l can be written as what? Root r plus j omega l into r plus j omega l, root r plus j omega l into root r plus j omega l, that can be written like this, divided by under root r plus j omega l g plus j omega c. So here this r plus j omega l, this r plus j omega l is cancelled. Finally, what is the remaining term you have? That is r plus j omega l divided by g plus j omega c. In the numerator, root r plus j omega l. In the denominator, root g plus j omega c. That can be written as what? It is in the form of root a divided by root b. That can be written as what? Root a by b. What is a? R plus j omega l. What is b? G plus j omega c. What is this v naught plus by I naught plus? Which is nothing but what? Z naught. It is the characteristic impedance. It is one of the secondary parameter of the transmission line. Why it is known as secondary parameter? This parameter is written in terms of the primary parameters R, L, G, C. So that's why it is known as secondary parameter of the transmission line. Or else, by equating the another similar term, what is the another similar term here? E to the power gamma x on left hand side, similar to this e to the power gamma x on right hand side. So that's why here you have what? V naught minus e to the power gamma x into gamma. Here we have minus I naught minus e to the power gamma x into r plus j omega l. That means another similar term is what? E to the power gamma x on left hand side, right hand also e to the power gamma x. By equating this you will get like this. Now let us write this one as minus v naught minus by I naught minus, here e to the power gamma x, e to the power gamma x cancel. You will get r plus j omega l divided by gamma. Already here we have r plus j omega l divided by gamma, which is equivalent to what? That is root. Already we simplified this one. We got this one as what? R plus j omega l divided by g plus j omega c. So this is the derivation of the characteristic impedance, which is equivalent to what? It is nothing but Z naught. So that's why Z naught can be defined in terms of V naught plus I naught plus, and it can be defined in terms of V naught minus I naught minus, V naught minus by I naught minus. Now let us write Z naught expression. That Z naught I am writing here. I am writing that Z naught is equivalent to what? In terms of the forward voltage, it can be written like this: V naught plus by I naught plus. In terms of the reverse voltage and reverse current, it can be written as V naught minus by I naught minus. Therefore, this equation 1, 2 can be written as, equation 1 is as it is, that is V of x is equal to V naught plus e to the power minus gamma x plus V naught minus e to the power gamma x. I am writing that I of x. Actually, here I of x is in terms of I naught plus and I naught minus. Here, I want to write that I of x in terms of V naught plus and V naught minus by substituting V naught plus as what? V naught plus as what? Or else, okay, by substituting I naught plus. Here, I naught plus as what? V naught plus by Z naught. That is 1 by Z naught into V naught plus e to the power minus gamma x, this term. And I naught minus, what is I naught minus? This one. I naught minus can be written as what? Minus V naught minus by Z naught. That is minus V naught minus by Z naught. That 1 by Z naught can be written here. V naught minus e to the power gamma x. Now here I am writing, here I have written voltage and current equation in terms of V naught plus V naught minus. Voltage is in terms of V naught plus V naught minus, and current is also in terms of V naught plus and V naught minus. That means instead of having 4 constants, here we have 1, 2, 3, 4 constants for voltage and current equations. Here we have 2 constants, V naught plus V naught minus. Here also V naught plus V naught minus for voltage and current equations. That is the advantage of the characteristic impedance. By using characteristic impedance definition, we can write voltage and current equations. Sorry. By using definition of characteristic impedance, we can write voltage and current equations in terms of voltage constants V naught plus V naught minus like this. That is the advantage of characteristic impedance. In next class, we can derive input impedance of the transmission line by using this voltage and current equations. Thank you.